Welcome back. This is section 2.8, one-to-one functions and their inverses. And so what we're going to look at now is what does it mean for a function to be one-to-one? And then once we understand what that is, then we can actually start looking at inverse functions of those one-to-one functions. All right, so first off, definition of one-to-one. So a function with domain A is called one-to-one if no two elements of A have the same image. Okay, so in this case, we're basically looking at the domain values here. Every value needs to map to exactly one distinct value in the range. Okay, so for every x, we're going to map to a distinct value in the y values. If you look at the second one over here, g would not be considered one-to-one because I have two different x values that are going to the same y value of 4, right? So 3 maps to 4 and 2 also maps to 4. Therefore, it's not one-to-one. This is still a function, right? Because every x goes to exactly one y. The problem is they're not all going to distinct y values, which is why we would say that's not a one-to-one function. Whereas the first function over here is a one-to-one function because every x is going to a different y value now, a distinct y value. Now, the way we can check for one-to-one graphically is we can use what's called the horizontal line test. Okay, so if I take a horizontal line and I pass it over my curve, as long as I never touch more than 1 point, then I know it's one-to-one because then for every x, there is a distinct y value. All right, so we want to determine first, in this case, is f of x equals x cubed a one-to-one function? So the first thing I'm going to do is I'm going to think about what does that graph look like. So we've talked about the x cubed graph before. And so if we were to sketch this now, this is my f of x, this is my x. It's going to go through the origin, and it's going to come up like this, kind of level out at the origin, and then continue up towards infinity that way. And so that's what our x cubed graph looks like. So again, the way we're going to determine if this is one-to-one is we're going to take a horizontal line and we're going to pass it over this curve, right? So I'm basically saying if I were to put a horizontal line and I were just to slide it up over my curve now, would I ever touch more than 1 point? And in this case, I never would, right? There's nowhere where that horizontal line would touch more than 1 point. Therefore, we would say that this is a one-to-one function. Now, let's look at the second one. This time we're looking at x squared. And I have my f of x, I have my x. Remember, x squared is just going to be a parabola whose vertex is at the origin. So it's going to open up like this on the right, and then open up like this on the left. Now this time, if I take that horizontal line and I pass it over my curve, notice here, it is going to touch more than 1 point. Okay, so in this case, because it doesn't pass the horizontal line test, we would say that this is not one-to-one. Because I have multiple x values where I get the same y value. So even though x squared is a function, it is not a one-to-one function. All right, now, definition of an inverse. Okay, so we're going to let f be one-to-one, right? So that's the first step, is it has to be a one-to-one function with domain A and range B. The inverse function, which we're going to notate as f with a little -1 like in the exponent, okay, that's read f inverse, has a domain B and a range A. So basically, we're just taking the x and the y values now of one function, we're switching the x and y, and that will give us the inverse function. Okay, so the domain becomes the range becomes the domain, we're switching x and y, that's how we find an inverse function now. Okay, but for us to have an inverse function at all, the original function has to be one-to-one. All right, so if we take a look here, we've got f of 1 equals 5, f of 3 equals 7, and f of 8 equals -10. We want to find f inverse of 5, f inverse of 7, and f inverse of -10. Well, in this case, if f of 1 equals 5, that tells us that our original function has a point at 1, 5. It also has a point at 3, 7. And then we also have a third point at 8, negative 10. So now I know that my inverse must have points at all the points where I switch the x and y values, because my domain and range are going to be switched now, which means the inverse function should have a point at 5, 1, 7, 3, and negative 10, 8. So if I'm looking for f inverse of 5, I'm looking for the y value when x is 5 in my inverse function. Well, looking at that first point there, that means that f inverse of 5 is just going to be equal to 1. Then we're looking for f inverse of 7. Same thing. I'm looking at my inverse points here. When x is 7, y is 3. So f inverse of 7 should be 3. And then finally, f inverse of negative 10. When x is negative 10, y is 8 for my inverse, so that value is going to be 8. Okay. But again, just notice here, all we're doing to find the inverse points is we're switching the x and y values, and then if you're looking for inverse values now, you're saying f inverse of the x value gives us that new y value. All right, now we want to find the inverse of the function f of x equals 3x minus 2. So the first thing I'm going to do, if I'm looking for an inverse of a function, I'm going to change my f of x to a y. We have y equals 3x minus 2. And because we know the inverse function is just switching domain and range, switching x and y, that's exactly what I'm going to do in my equation. Every y is going to become an x, and every x is going to become a y. So I've just changed my y's to x's, my x's to y's. Now I'm going to solve this equation for y. So if I do that, I can add 2 to both sides. It's going to give us x plus 2 equals 3y. Then we can divide by 3. And keep in mind, we need to divide every single term when we do that. So that's going to give us 1/3 x plus 2/3 equals y. This now represents my inverse function, so I can say f inverse of x is equal to 1/3 x plus 2/3, and this would be my answer. So again, the general steps here, if you have an f of x, go ahead and change it to a y. We're going to switch our x and y values, solve that equation for y, get y by itself, and then just make sure, since we found an inverse now, we want to label it as an inverse function. So we're going to write f inverse of x equals whatever that function is now. All right, so now we've got the inverse function of this rational function, 2x plus 3 over x minus 1. Again, our steps are the same. First thing I'm going to do, I'm going to rewrite this as y equals 2x plus 3 over x minus 1. Because I'm looking for an inverse, I'm going to switch my x and y values. So my y becomes an x, and this time I have multiple x's over here. Both of them are going to become y's. Now I need to solve for y. Well, the first thing I'm going to do is I'm going to get rid of this fraction. So I'm going to multiply both sides by y minus 1. And when I do that, I'm going to have x times y minus 1 equals 2y plus 3. All right, now my next step, I'm going to distribute the x, and we're going to end up with xy minus x equals 2y plus 3. Again, keep in mind we're trying to get y by itself here. That means I need to get all of my y terms to one side, everything else to the other side. So I'm going to start by subtracting 2y on both sides. We're going to have xy minus 2y minus x equals 3. The only term that doesn't have a y now is the x, so I'm going to add x to both sides. So now we're left with xy minus 2y equals x plus 3. And my next step now, since I have two terms that both have a y, I can actually factor out the y term. So I'm going to factor out y, and that leaves us with x minus 2. Still equal to x plus 3 now. So then our last step, we just need to get the y by itself. So I'm actually going to divide both sides by the x minus 2 so that that factor cancels, and we're left with y equals x plus 3 over x minus 2. Once we've got y by itself, now we're done. That is our inverse, so I'm going to label it that way. This is f inverse of x is equal to x plus 3 over x minus 2, and this is our final answer now. But again, in general, the steps are going to be rewrite f of x as y, switch your x and y values. If you have multiple x's or y's, make sure you're switching all of them. Then you're going to resolve that equation for y, get y by itself, and then just label it as f inverse once you get y by itself. All right, example 10 now. We want to sketch the graph of f of x equals the square root of x minus 2. So first off, we have a square root function. That would be our parent. We know the minus 2 is going to shift the graph to the right 2 units based off of our transformations. The minus 2 on the inside is going to shift it to the right. I'm going to sketch this now. Remember, the square root function would normally start at the origin. So if I shift it to the right 2 units, it's going to start right over here. And it's going to open up and to the right. So we're going to have something that looks like this. All right, now, if we want to use that to sketch the graph of f inverse at this point, remember what we're doing to find an inverse function is we're switching our x and y values. So let's think about what would happen if I were to switch my x and y values this time. I'm going to call this f inverse of x. Well, I know I have a point at 2, 0 as my starting point. If I switch the x and y values, though, that point's going to become 0, 2 instead. So I know my graph is going to start up here at 0, 2. Now, as I go on, right, I can think about some of these other values. If I were to do like a point at 3, if I substitute that in here, 3 minus 2 is 1. The square root of that is 1. So I'm going to actually have a point at 3, 1 on my graph. Switching those points now is going to give me 1, 3 as a point on my graph. So I'm going to have a point at 1, 3. It's going to look like this. Now the next value that's going to be easy to think about would be 6. So 4, 5, 6. If I go to 6, 6 minus 2 is 4. The square root of 4 is 2. That tells me when I get out here to 6, I should have a point on my graph at 6, 2. That means that 2, 6 should be a point on my inverse graph, right? And if I squeeze that in here, there's 4, 5, 6. I'm going to go over here, up here. And you should be able to start seeing what this graph's going to look like. So it starts here at 0, 2, and it's going to curve up and to the right like this now. So this would represent my inverse function of the original square root function. Now, if we look at that graph, what you can probably notice is it looks like half of a parabola. And so in that case, we know that the inverse function is going to be like an x squared function. It shifted up 2 units this time. And so our equation for f inverse of x is just going to be x squared plus 2. Now, just to show you that we could have done this algebraically also, right? If I were to start up here with y equals square root of x minus 2, to find the inverse, we would switch x and y. So that would give us x equals the square root of y minus 2. Now to get y by itself, I could square both sides. That's going to give us x squared equals y minus 2. And then adding 2 to both sides would give us x squared plus 2 equals y. And that's exactly what we've got down here now for our inverse function. Now, one thing we have to be careful of here is that the domain of this function, this inverse function, is related to the range of the original function. So we know in this case now that the original function had a domain from 2 to infinity, which means that our new graph is going to have a range that's exactly the same from 2 to infinity. And we can see that on the graph, right? 2 is the smallest y value, and it goes up towards positive infinity. Now, the range of the original graph started from 0 and went to positive infinity, which means that the domain of my inverse, since I'm switching x and y, is going to go from 0 to infinity now. So that's why we only end up with half of a parabola, because it only starts from 0 and goes to the right. We're not going to get everything to the left this time. So just be very careful when you're talking about these inverse functions. Even though the inverse is x squared plus 2, its domain is restricted from 0 to infinity because the range of the original graph was restricted from 0 to infinity. All right, and that's everything we're going to cover here in section 2.8. As always, ask me questions using Ask My Teacher button in WebAssign if you have them. Come see me during student hours if you need to. Otherwise, have a great day, and I will see you next time.